Welcome. I hope
Hi.
everyone's having a wonderful time in the conference. Up next, we have Carly. Carly is a developer advocate at Elastic. Prior to Elastic, she spent over a decade working as a technologist at a large investment bank, specializing in front end web development and agility. She's an agile evangelist, UI enthusiast, and regular blogger. Welcome, Carly.
Thank you. Thanks for having me. It's lovely to see everyone. Hi. So, today I'm going to talk about a problem that I've actually seen for a proportion of my career when I worked in an investment bank. And the main problem I'm going to talk about is regarding adoption of features and user experience. Trying to determine this is something that I've always really struggled with as a front end developer, yet it's something that's critical to my understanding of how I can build better software. And today, that's exactly what I'm going to talk about. I'm going to talk about why it's a hard problem to solve, how we can do this in a more quantitative way, and how we can use tools such as Google Lighthouse, synthetic monitoring, and elastic real user monitoring to achieve that. Okay, so as I said, I used to work at a bank. And within that time, I used to work in a mixture of waterfall, scrum, and Kanban paradigms, depending on the team, which meant that we did a lot of reviews with our users talking about features. And I found, to extend the analogy, reviews were really similar to giving gifts at Christmas or birthdays. And normally you'd have one or two particular scenarios working. Either they would immediately open up, see the new features, and they would think it was great. They wouldn't stop talking about it. They would be super excited. Most likely I would come away from those sessions with a list of, so many other items to add to the backlog. It was great. And you knew straight away from that things were great and that this feature was most likely going to be adopted. And then sometimes you got something that I would more akin to that moment when you get that awkward Christmas jumper that looks a bit itchy and uncomfortable and not quite your style, where you get a kind of smile and a nod and you don't really get any information at all. And particularly if you're working with people that you know very well, you work within the same company, it can be really difficult and awkward sometimes to get that negative feedback. And the reality is that's a problem because do you know when we find out about it? When the panic station hits, when red alert starts going off and you're running as a developer to your console to an escalation, searching through logs and panicking and trying to figure out what's going on. And normally, when the lights turn back to normal again, the panic is over, it was always these points when I thought, could I have caught this earlier? Was there other means in which I could have got better feedback earlier? So I'm going to tell you a little story. And it was basically one of the main turning points for me where it made me realize I need to do something else about this. So once upon a time, in a very large investment bank, a group of eager developers had been busily building new features for months, regularly showing the features to users, and had a very happy sponsor at the end of it. Yet a few months later, we're getting a phone call in a panic saying, the screens are slow, we don't know what's going on, the analysts don't want to use this, you need to fix this right now. So we're diving through the server logs, everything seems to be ticking fine, but it's obvious from the front end that something is wrong. And I had a colleague come to the rescue. He pulls up Chrome developer tools and we start looking through the profiling, so using the flame graph to see what's going on. But we also started using a tool called Google Lighthouse, which you can see on the screenshot in front of you. And this was the first time that I got to see some example metrics that I thought I could use to determine web performance and the user experience in my applications. And these metrics are called Core Web Vitals. They were initially announced by Google in May of 2020, and they're a series of measures that are used to evaluate the user experience of websites. For anyone who's looking more from a search engine optimization perspective, you might have heard of these too. And the reason for that is that they were included as part of the core search ranking criteria in Google as of June 2021. So there's three primary measures that we're going to talk about today that are the main part of the suite. And the first of which is called largest contentful paint. LCP is basically an indication of that initial response time. So when a user is navigating to your site, are they actually going to be able to see something? Or is there a potential that they might think your site is unavailable and maybe end up going somewhere else, perhaps to a competitor? Ideally, we're talking about a measure of 1.2.5 seconds, and the render time that I'm talking about here is about the largest image or text block that's visible within the viewport. So as I said, that initial experience for a user. The second measure we often talk about with Core Web Vitals is what's called first input delay. Now, FID is about user responsiveness. So it is the time for when a user inputs an action, such as a click, and when that corresponding command is executed. And ideally, you want this to be under 100 milliseconds. We've all been there in that situation where we think a site has not responded to a click and we start mashing again on the mouse or on the keyboard. And 100 milliseconds is round about the threshold when you start thinking something's not quite right. And then the final measure, which I consider the most complicated, and the one that maybe we don't initially think is important, but it really is cumulative layout shift. It might seem a bit strange that we're talking about movements and layouts in web pages, but the fact of the matter is that if you have a page that is moving around a lot and is unstable, that means there's more of a chance for user error. We've all been in that situation where another option pops up above the one we want and we end up inadvertently hitting the wrong thing. So your CLS is calculated from all of the shift scores across the entire lifetime of the page. So all the ratios of movement are calculated, and then the largest burst is your CLS for the page. And that should ideally be under 0.1. So we can calculate these using Google Lighthouse, either within Chrome Developer Tools, as I showed before, or also we can do smart things like including them using plugins in our continuous integration pipelines, or even running them ad hoc as reports on the command line. And it's a great point to do this at different stages in your development cycle. But one of the problems I've found is normally I'm using Google Lighthouse when it's too late because I've already detected with my spidey sense that something is wrong. And while this gives us the Core Web Vitals and the opportunity to evaluate the user experience, it doesn't address the question of are our users indeed using it? So we know we need something else. And we know as well that potentially if we're doing the recording function for this, that we're going to be making assumptions of what the user workflow is, and we're capturing metrics on that rather than what they're actually doing. So one way that I've seen people try to rectify this, because they don't really want to spy on their users and monitor them, is we use synthetic monitoring. So I'm sadly not talking about having my lovely workmate Pepper here sitting with you, actively running the workflow against your website. I'm talking about the use of scripts and workflows to basically simulate the behavior a user might engage in. And you can do this in one of two ways. You can either trigger regularly an endpoint, such as an HTTP service every 10 minutes or so, or whatever your frequency is that you desire, and see that it's still alive. Or you can make use of more sophisticated things such as browser monitors, which normally use scripting technologies such as Playwright, which I've got here, in order to emulate the user workflow, similar to end-to-end testing, if anyone's done anything like that, and be able to basically see every 10 minutes if that workflow is running as expected. Is it perhaps starting to lag and slow down, in which case there might be a degradation of performance to look at, or even if particular steps are failing. And synthetic monitoring is a great way to try and look at the performance of a website. However, it still doesn't answer that question of are they really using it? So we need something else to complement these technologies, and it's time to crack out the rum. Now, I am not talking about favorite alcoholic beverages, pirates. Sorry, I know it's early in the morning for everybody. But what I'm talking about is real user monitoring. And this is a mechanism for collecting navigation information, errors, and other metrics based on the real user behavior against a website. You might have heard of OpenTelemetry, which in observability circles is the open standard for an open protocol for capturing traces. Sadly, there is not a RUM equivalent at this time. There's a great proposal, so anyone who's interested to go check out the GitHub. However, what you can use is real user monitoring agents for whichever observability platform you are using. So the way they work is that they'll run alongside your JavaScript application. I'll show you how to instrument the agent in a moment. And then in the case of Elastic, although other observability providers will do something similar, all of the traces and metric information will be sent to the integration server, so APM integration, which will persist the data down into an Elasticsearch index, and then you will be able to see the particular traffic and messages either via the apps within Kibana that are dedicated to observability, case in point, user experience dashboard, or also within Kibana Discover, where you can build your own dashboards too. So I promised you some instrumentation. I have some code here I'll walk through briefly. But if you want to dig into this or examples on instrumenting backend services with APM, I've got a handy link at the bottom in the QR code. Go to the GitHub, have a look at the code, and please do contact me with any questions or if you want to chat through any thoughts. So it's a case of using the Elastic APM RUM dependency installed via your favorite package manager, so npm or yarn. And then what you'll do is you'll run the initialize command, passing in the name you want to give your service, known as the service name. You'll pass in for any cross-origin requests, the URLs that you're going to be sending them to, because by default, although it enables distributed tracing, it's only done on a single origin with the agent, unless you specify that option. You'll specify your Elastic cluster, and then you have optional attributes such as the environment and service version if you want to get into more detailed view and compare changes over time. You might be wondering if you're using particular JavaScript frameworks. Well, does that change anything? Only slightly. So you might need to make use of an integration to take advantage of custom error handling or routing that is given on top of these frameworks. And the example I've got in here makes use of APM RUM React, which is the additional NPM dependency or yarn dependency you'd need to install. And you can see I'm using that route in place of my traditional React route or DOM route, which will capture the navigations for me. Simple. If you want to dig in, please check out the GitHub, the codes at the bottom corner, or if you ping me afterwards, I can send it to you. So I now have information that I really wish I'd had at the time when I was a front-end developer. So if I could hop back in my DeLorean and travel back in time, just like Marty from Back to the Future, I would be taking RUM with me and trying to use it to solve some problems that I had in my time as a front-end engineer. So I'm going to talk through some stories in the remaining time and show how I would use RUM to solve these problems. So let's go back to that performance story that proved to be the kind of wake-up call for me. And one of the issues I highlighted was that we weren't sure where the problem was. We were diving through into the server logs as well as looking at the front end to try and identify the issue. So being able to have core web vitals was one of the things that proved to be a turning point. But rather than having to calculate it using Google Lighthouse and a custom instrumentation, if you make use of RUM, the dashboard will actually calculate what these vitals are based on the real user traffic, which can be a great time saver if you are running about in an emergency trying to fix something urgently. But because it's also capturing the real user behavior, it also gives you traces, which anyone from an observability background might be familiar with views such as this. So what you'll see here is I've got two services being captured. I have in green the front end, which basically it shows you the key execution time for loading of my JavaScript files, for triggering the calls on that side. And then you can see the subsection in blue, which is my backend Node.js server. And in fact, the majority of the time is taken up with front-end transactions in this case, which can be a useful thing for identifying bottlenecks. The second challenge I sometimes came across was that I would get conflicting accounts from users. Now, I was in a privileged position. All my users sat a couple of floors down from me when I worked in one particular team. And I could just hop down and ask them what they thought about things, in addition to trying to get feedback in those reviews I talked about. But one of the things that was interesting was I would get different answers depending on who I spoke to. So some users were really early adopters and would use features very quickly and straight away. Some might have used it once or twice, but then fell back to their old process. And then some might not have heard about it. Maybe they were on holiday or out sick when that review happened, and that information hadn't maybe permeated through. So they give you aggregate information when you use RUM agents such as this, and the total page view that I've got highlighted up there is a key example. Being able to see the total views of a particular page and subpages as well is vital when you're looking at adoption. Not just because you want to see if there's a general upward trajectory, but also if you want to see if there's patterns, perhaps planning for capacity. We know that there's particular times that might be especially busy. So, for example, Black Friday for e-commerce is a big one. But there might be particular spikes or frequencies that you might not know about. So, for example, maybe they thought they were going to use this feature monthly, and it turns out they're only using it quarterly. Knowing these kinds of things can help us plan for capacity, plan for support, and maybe ask some questions about how the feature could be adapted if there's something perhaps missing that we need to consider. Sometimes it doesn't work for one particular user. We've all had that joke, it works on my machine when we've been writing code, right? Well, I've had the situation where it doesn't work on one particular user's machine, and I've not been sure why. But it's worked for everybody else, and they're all happy. And I know they're using it because I'm getting great feedback and I'm getting a ton of feature requests as well. So in this particular case, I actually turned up at this individual user's desk one day and I wanted to see what they were doing. And I found some information I'd struggled to get from chatting over the phone. Firstly, they were using Internet Explorer, which the application had not specifically been built to support. And the second thing that was of interest was that they had some custom cookie settings that were enabled, which had to be cleared out. And then, ta-da, by magic, it worked. And I was able to tell that through using the Chrome Developer Tools console, so I could see the stack trace within there. You're not always going to be able to do what I did and hop over to your user's desk. So how do we get this information? Well, RUM captures it too. It captures information about the agent that's accessing the site. So as you'll see here, I can see a visitor breakdown in the first pie chart there, which is each of the individual browsers that are using this particular site. And then I can also see the operating systems as well. Now, some people might still, in particular domains such as healthcare, still need to support Internet Explorer. But even in the future, there might be browsers that are dying off, that are being decommissioned, that you need to consider if you need to warn your users off using it or provide support for that browser. Furthermore, if you're not using a mobile-first development strategy, you might want to see what different operating systems and devices are accessing in order to plan, do we need to make a move to mobile development? Do we need to build out that desktop app when we started at mobile, and vice versa? Sometimes those errors are going to appear. So rather than having to rely on me walking over and seeing the console, just being able to see the occurrences of these particular errors over time, see the stack trace, and also the metadata associated with it. So you'll be able to see in the error occurrence just underneath, it does actually say which browser is using this. And then if you want to do smart extensions, you'd be able to see the metadata as well and the stack trace. This requires uploading of the source maps because obviously for production code, you'll be using minified JavaScript, and this source maps allow you to kind of reverse engineer to see the traces. But obviously this information is vital as well, so that you're able to basically see what's happening remotely without having to necessarily dig around in the console on a user's computer. So the last...
Yes, go ahead with the last part. We need to wrap. Sorry about that.
Yeah, no worries. So the last thing is that sometimes they might not be, you might think they're not using it, but they are. I know that sounds a bit strange, but particularly if you're working for large institutions that are trying to reduce their footprint, decommission legacy software, you will probably need to know if it is indeed being used and get assurances before you switched it off. And I've had this situation before where, despite assurances, I've found that it is indeed being used on bank holidays in one country. And that would have been really difficult to find had it not been from looking through the network logs. However, if you make use of these controls in a way that you might not expect, you can answer these questions. So taking a look at page load by duration by region actually gives you not just the idea of seeing where low bandwidth items are, bandwidth countries are, but you're also able now to see as well where in the world it's being used. So with all monitoring, of course, I have to put the reasonable responsibility disclaimer up. Make sure you use these metrics responsibly. They are not meant to be for spying on your users. They're meant to be for improving your application. So use them with that ethos in mind. And thank you very much for your time, everyone.
Thank you so much. This was wonderful. Bye, everyone.
Bye.